Hello my dear students, today onwards we are going to start our online lecture of subject Mechanics of Solids, that is MET 201 Mechanics of Solids. Mechanics of Solids. This is the first video lecture regarding this subject. Before going to this subject, we have to know some basic fundamentals regarding this subject for the clear-cut understanding of this subject. Okay, let's start. We have to know what is the term force. You are very familiar with this term, the term that is force. From high school class onwards, you are familiar with this term. Okay, what is force? What are the classification of force? What are the type of force? What are the effect of the force on a body? Etc. like that. Then what is force? Just recollect the definition of the force. Okay. What is force? Force is an agency which changes or tends to change state of rest or uniform motion of a body. Okay. Consider a body which is under stationary condition. What is the definition of force? Force is an agency which changes or tends to change state of rest, that is body is at a stationary condition. When an external force is applied in the member, what will happen? The body may displaced from one position to another position, that is body is displaced from this position to another position. Or consider another body which is under motion. When an external force is applied in the member, what will happen? What will happen? The body becomes under body may becomes come to the stationary condition, otherwise body is displaced from one position to another position or changes its direction. These are the effect of the forces. You are very clearly know about what is the effect of the forces. Okay, next today, what is load? What is load? What is the unit of force? Unit of force is Newton. Unit of load is Newton. Then what is the difference between force and load? The point of application of a force is known as load. What is load? Point of application of a force is known as load. Otherwise, load can be stated as a force which need direct physical contact is known as load. A force which need direct physical contact, that is which makes direct physical contact with a body, then that force is known as load. When a force which need direct physical contact, which is known as load. Okay, the force which need direct physical contact is known as load. Consider a simple example, that is magnetic force. Magnetic force. Have you heard about this term? Magnetic force. What is the significance or what is the importance of magnetic force? In the case of magnetic force, there is no direct physical contact. Okay, then we cannot say magnetic force is just like a mechanical load. That is, magnetic force is not a mechanical load because it has no direct physical contact. Okay, then what is force? Force is an agency which changes or tends to change state of rest or uniform motion of a body. What is load? Point of application of force is known as load. Otherwise, a force which need direct physical contact is known as load. That is the difference between force and load. Both of them have same unit, that is Newton. Okay, now we can move to the another term, that is what is rigid body and deformable body. What is the concept of rigid body and what is the concept of deformable body? What is the concept of rigid body and what is the concept of deformable body? Okay. Consider a body. Let A and B are 2 points in the body or position of two particles are shown in the figure. An external force having magnitude F is applied on A and B. Okay. Then what will happen? If the relative position of the particle is get changed due to this external force. Okay. If relative position of the particle is changed due to this external force, then it is known as a deformable body. that is relative position of the particle is changed due to the external force, then it is known as a deformable body. If relative position of the particle does not change with respect to the external force, then it is known as rigid body. Okay, what is the definition of deformable body? If relative position of the particle is getting changed due to the external force, then that body is known as deformable body. If relative position of the particle does not change with respect to the external load, then it is known as rigid body. Okay, then what is the concept of rigid body and what is the concept of deformable body? Okay, the relative position of the particle is changed with respect to the external force, then it is known as deformable body. The relative position of the particle does not change with respect to the external force, then it is known as rigid body. Okay, then we can move on the another term. What is the effect of force, or what is the effect of load on a body? What is the effect of force, or what is the effect of load on a body? That is, what is the effect of force or effect of load? Effect of load on a body. Okay, consider a member. An external load is applied in the member, that is equal to having magnitude that is equal to F. Okay, external force is applied in a member. Then we have to know what is the effect of this force in the member. Consider two particles, that is A and B. Okay, consider two particles, that is A and B. Okay, then what will happen due to the application of this external force, that is A and B? Then what will happen for the particle A and B due to the external force? That is, this force is acting towards leftward direction and this force is acting towards rightward direction. What will happen to this body? That is extension or stretching. That is elongation takes place in the body. Okay, then what is the nature of force? This nature of force is known as pulling nature. Okay, pulling nature. This type of force is known as tensile force. This type of force is known as tensile force. Then what will happen for a tensile force? When a tensile force is applied in a member, then the body will elongate or stretch with respect to that force. Okay, that is pulling nature of a force which acts on the body, which will elongate or stretch a body, then it is known as a tensile force. Similarly, what is compressive force? Consider same body, two particles, that is A and B. That is A and B. Two force is applied in the member, that is F. Then what is the nature of force? That is pushing nature. Okay. Then what will happen to the particle A and B? Then A and B will comes very close or nearer to each other. What will happen on here? That is, it will move away from each other. Okay, move very close to each other in the case of this one. That is, nature of force is known as compressive. What will happen? Compression or contraction takes place due to the application of this force. Then this nature of force is known as compressive force. That is, compression or contraction takes place, then the nature of force is known as, that is, compressive force. Both tensile and compressive force are normal forces. Both tensile and compressive force are normal forces because it is acting normal to the surface. Therefore, compressive force and tensile force is also known as normal forces. Okay, what is the effect of force? What the first force is tensile. When tensile force is applied or tensile load is applied in a member, then the member will extend, elongate or stretch. When a compressive force is applied in a member, then the member will compress or contract, or its length will decreases. That type of force is known as, that is the effect of force, that is compressive force. Okay, first one compressive force, first one tensile force, second one that is known as compressive force. Okay, next today, that is the torque. Consider a member which is applied by two equal and opposite forces. You know that when two equal and opposite forces acting certain distance apart constitute a couple. You have already studied this term in first year engineering mechanics. Okay. When two equal and opposite forces act on a member, then it will generate a couple. This couple will twist the member. This couple will twist the member. This couple will twist the member. Then the nature of force is known as torque. This effect is known as torque. Okay. With twisting effect created, when a couple of forces are acting on a member, then twisting effect is created, then the nature of force is known as torque. Okay, then first one compressive force, next one tensile force, next one torque. Then what will happen when tensile force is applied in a member? When a tensile force is applied in a member, the member will extend, that is stretched or elongated. What will happen when a compressive load is applied in a member? When a compressive load is applied in a member, the member will contract or compressed. Okay, what will happen when a torque is applied in a member? When a torque is applied in the member, then each and every layer will become twisted. Okay, that effect is twisting effect is known as torsion like torque. Okay, next one, that is bending effect. Consider a member which is supported. When a load is acting perpendicular to the longitudinal axis or perpendicular to its axis, what will happen? It will bend like this. Then nature of force is known as bending force. Bending force. Okay, that is a simple one. Okay, next one. What is shear force? Consider a member equal. This is a section line. Consider a member. When a series of parallel and equal forces acting just like this, they are not collinear in nature. What will happen? The member will cut about this axis. Then that cutting or breaking force is known as shear force. Shear force. When a number of equal, opposite, parallel forces acts on a member which are not in collinear nature, that may create a breaking or cutting in the member, that is known as shear force. We are dealing with these forces detailed in this module. Okay. Then first one, what is the effect of tensile force? What is the effect of compressive force? What is the effect of torque? What is the effect of bending force? What is the effect of shear force? Okay. Now we can move on the next time. What is mechanics? You are already heard about this term mechanics, that is engineering mechanics. Okay, here we are dealing with what is mechanics. What is mechanics? Mechanics is the branch of engineering science which deals with study of behavior of a body. Mechanics is the branch of engineering science which deals with study of behavior of a body under the action of load or force or energy, whatever may be. Mechanics is the branch of engineering science which deals with study of behavior of a body under the action of load or force or energy. Okay. Mechanics can be classified into okay, first one, mechanics of rigid body. Mechanics of rigid body. Next one, mechanics of deformable body. Second one, mechanics of deformable body. Okay. Next one, mechanics of fluid. Okay, that is, what is mechanics? Mechanics is a branch of engineering science which deals with the study of behavior of a body. Okay, mechanics can be broadly classified into mechanics of rigid body, mechanics of deformable body, mechanics of fluid. That is, mechanics of rigid body is also known as engineering mechanics. Engineering mechanics. Mechanics. That is, what is engineering mechanics? Engineering mechanics is the branch of science which deals with study of behavior of a rigid body under the action of load. Under the action of load. Okay, next one. What is the mechanics of deformable body? That is known as mechanics of solids. Mechanics of solids or strength of material. Mechanics of solids or strength of material. And the mechanics of fluid is also known as, that is MOF. Mechanics of fluid, MOF is known as, that is fluid mechanics, that is equal to F1. Okay, along with mechanics of solids, we are studying fluid mechanics in the same semester, that is S3. Okay, then what is mechanics of solids? We are dealing only with the mechanics of solids. What is mechanics of solids? Mechanics of solids is the branch of engineering science which deals with the study of deformable body under the action of load. That is, what is mechanics of solids or strength of material? Strength of material or mechanics of solids is the branch of engineering science which deals with the study of behavior of a body under the action of behavior of a which body, which type of body? That is deformable body under the action of load. Okay, then we are dealing with some terms, that is, what is force, what is load, what is rigid body, what is deformable body, what is the effect of load, that is, what is the effect of tensile load, compressive load, torque, bending, shear, etc. like that. And then what is the unit of force and what is the unit of load. Then we are moving to what is mechanics, what is the branch of mechanics, that is equal to mechanics of rigid body, mechanics of deformable body, and mechanics of fluid. We are dealing only with the mechanics of deformable body or mechanics of solids. What is mechanics of solids? It is a branch of engineering science which deals with the study of behavior of a body, that is study of behavior of a deformable body under the action of load. Then what will happen when a load is applied on a member? That may be break, that may be elongated, that may be compressed. That are the effective forces. That is already says that like that. Okay, we can directly move into the subject. Okay. Okay, first day, what is stress? So we are starting mechanics of solids. Consider a body. An external force is applied in the member. Then what is the nature of force? What is the nature of force? Tensile or compressive? It is tensile force. When a force is acting away from the body, then it is known as tensile force. When a force is acting towards the body, then it is known as compressive force, tensile force. Okay. For every action, consider a section line. We know that for every action, there is an equal and opposite reaction. Okay. For every action, there is an equal and opposite reaction. Okay, that is equal to F. This is the section line which I have drawn. Okay. For every action, there is an equal and opposite reaction. Therefore, there will generate a resistance inside the body against the applied force. Then applied force is acting towards left. Therefore, resistance is acting towards the right. Suppose resistive force generated in the body, that is equal to P. Resistive force generated in the body, that is equal to P. Then what is stress? Stress is defined as this resisting force generated per unit area, which is known as stress induced in the member. That is stress is equal to resisting force generated per unit area. Per unit area is known as stress induced in the member. What is stress? That is resistive force generated per unit area, which is known as stress induced in the member. We are dealing with mechanics of solids. In the case of mechanics of solids, the important assumption is that the body is at a static equilibrium condition. The body is at a static equilibrium condition. That is, at the equilibrium condition, body may stretch, elongate, or compressed, or twisting effect takes place. Therefore, that is, important assumption is that external force applied in the member, which is equal to resisting force generated in the member. That is the important assumption in mechanics of solids. Therefore, stress is equal to resisting force, that is equal to P divided by area. Stress is equal to resisting force P divided by area, or stress is equal to force divided by area. That is P is equal to F. Okay, that is what is stress. It is a resistive force generated per unit area, which is known as stress induced in the member. Resistive force generated per unit area, which is known as stress induced in the member. The area is taken under an assumption that area is taken which where the force is applied. There is force is applied here, therefore this area is taken. Okay, force is applied this region, therefore this area is taken. Okay. Consider a body. Force is applied this side. This is equal to B. This is equal to thickness of the member. That is equal to length of the member. That is equal to F. Then we know that stress is equal to force divided by resistive force. That is F divided by area. What is the area here? Area is equal to B into T. If force is applied here, what will happen? Then area is equal to length into width. That is L into, that is equal to B. Okay. Force is applied on this face. Therefore, area is equal to length into width. That is length is equal to width. That is B into T. When the force is applied on the top face, then area is equal to length into L into B. Okay. In the case of a circular member, what is the area? That is stress is equal to force divided by area. That is area is equal to area of the circular section. That is equal to pi by 4 into d square. This is the diameter of the member. Area of the circle, that is circular section, that is pi by 4 into d square. We are dealing these concepts in detail in the problem topic. Okay. Okay, what is stress? The resistive force generated per unit area is known as stress induced in the member. Okay, thank you.